Okay, in this lesson, 2C, we're going to talk a little bit about probably two things you have not heard of before, but they are related to things you just did or things you have heard of before. So the first thing we want to do is we're just going to review circumference real quick. So by definition, the circumference is the distance around a circle. We found out in the last lesson that the formula for circumference could be 2 pi r, or circumference could be pi d. Okay, so if I come over here and I know the radius is 3, I'm going to use the circumference formula that has the radius. So circumference equals 2 times pi times 3, and when I multiply those together, I'm going to get 18.8, and this is inches. Circumference is in inches. Okay, now here's the new term, arc length. You all know what arcs are, and arcs normally are measured in degrees. When we talk about arc length, we're talking about the length of a piece of the circumference. So circumference is the distance around. So like if I had a string and I made a circle, okay, I could take that string and straighten it out and find how long it is. That's called the circumference. An arc length is how far is it from here to here. Okay, if I would take this piece of the circle and I'd take my fingers and I'd put one on each end and I would straighten that arc out, I could measure that and that would be my arc length. So we're not necessarily talking about the degrees because we know this, the number of degrees for this arc is 100. This is a central angle equals its arc. We're not talking about the number of degrees that arc is. We're talking about if I was going to walk from this point to this point, how far would I walk? I'm not going to say I walked 100 degrees. I'm going to have a certain length that I'm going to do. Okay, so this is a piece of the circumference. Okay, so that piece is however many degrees, and that's the symbol that we use. How many degrees out of the 360 are we using? Then we're going to take that times 2 times pi times r. So this is a fraction. Okay, this is just a piece, so it is a fraction of the whole circumference. Okay, so let's fill in these pieces. So you can see there's really only two unknowns, the angle or the arc measurement and the radius. So when I look on this picture, I can see the angle that goes with this arc is 100 degrees and the radius is 7. So in place of the angle, it's called a theta, okay, is what we use in place of an angle. I'm going to put 100 over 360 times 2 times pi times 7. Okay, now how you multiply that together is lots of different options. My best advice, okay, since this is multiply and these are all on the top, is that you multiply all the way across the top. So you're going to take 100 times 2 times pi times 17, then push equals, then push divide by 360. If you don't push equals, it's only going to divide the last, well, depends on how you put things in. It might be okay, but I always just err cautiously by pushing equals at the end of that multiply. You'd probably be okay because it's multiply and divide. I'm just thinking order of operations there. So if we do it going across here, I'm going to take 100 times 2 times pi times 7, divide all of that by 360. That will tell me the arc length, and usually we just use AL, arc length, is going to equal 12.2. Now if you use your calculator and don't get 12.2, please ask so I can show you for sure how that goes into the calculator. So again, arc length is just a fraction or a part of the circumference. Okay. Area of a circle we found in our last lesson was pi r squared. Okay, so if I'm looking at this picture, r is 9, so pi times 9 squared. If I multiply that, 9 times 9, get 81 times pi. Multiply that out, I get 254.5, and this is area now, so my unit measurement or my unit labeling will be square centimeters. When we're talking about circumference and arc length, we're talking about just linear. Okay, so that's all we have to do for area of a circle. A sector is the area of a piece of the circle. Okay, and that piece of the circle is surrounded by a radius on one side, a radius on the other side, and an arc on the third side. So it's kind of like a piece of pie or a piece of pizza. It is radius and the arc. So since this central angle is 70, the arc is 70. So a sector is a part of the area. So just like we did up above, that fraction or that part is going to be how many degrees out of everything is the sector we're talking about. So like this one, we're talking about just this little piece right here. Okay? But it's that fraction of the whole thing, which is pi r squared for area. Okay, so it's a fraction of the whole area will give me the area of just this little piece. Okay, called a sector. So let's see how that works for this one. So remember, this theta is the angle of the piece we're talking about. So this is 70 out of 360. So that's the fraction of the area. Oops, it should not be there. Pi 5 squared. Okay, so again, you can multiply this out however you want. I would suggest just multiplying across the top first and then taking that result dividing by 360. So in this case, again, since these are all multiplications, it doesn't matter what order I do them. I would probably suggest you do this piece first, okay, with the exponent, because otherwise things can get messy if you don't put them in the right order. So I would take 5 squared, or 5 times 5, 25, times 70 times pi. That result divide by 360. And when you do so, you get the area of the sector to be 15.3 square feet, because sector is an area and our labeling needs to be square. Okay, so these are two things that you probably haven't heard of, but I think if you understand that arc length is just a fraction of the circumference, and area of a sector is just the fraction of the area. Okay, we'll end there with part one. We won't do this down here, and we'll come back and do some examples for you.